Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through the first part of the graphs where we have seen how we can plot the graph of linear functions, linear inequalities and so on. In case if you haven't gone through that video till now, the link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In today's video, we are going to see how we can plot the graph of quadratic functions. So let us start with today's video. Before seeing this video, I would suggest you all to go through the quadratic equation videos first, as many concepts of quadratic equation has already been covered there. So it would be very helpful for you all to go through those videos first and then to come back to this video. The link of those videos I have already given in the description box. The standard form of a quadratic equation is given by y equals to ax square plus bx plus c, where a is the leading coefficient and it is non-zero, and b and c are some constants. Now, if we put these constants b and c to be 0, and if we put the value of the leading coefficient as 1, in that case, we'd be getting the quadratic equation as y equals to x square. Now, if we put different values of x, we'd be getting different values of y. And if we put these values in the x and y coordinate axis, in that case, we'd be getting the graph of y equal to x square. For example, at x equal to 0, the value of y will also be 0. In a similar way, at x equal to plus 1 or at x equal to minus 1, the value of y will also be 1, say somewhere here. If we put x equal to 2 or minus 2, the value of y would be plus 4, let's say somewhere here. In a similar way, if we put x equal to plus 3 or at x equal to minus 3, the value of y would be 9, say somewhere here, and so on. Now, if we join all these points, we'd be getting the graph of y equal to x square, which would be something like this, that is a parabola. Also, we can notice here that the value of y is non-negative and the minimum value of y is 0, since the value of x square will never be negative and it will always give us a positive value. In a similar way, if we draw the graph of y equal to 2x square, in that case, we'd be getting this graph, which would be steeper as compared to y equal to x square, as the magnitude of the leading coefficient is higher in y equal to 2x square as compared to y equal to x square. So for the same value of x, y will achieve a higher value in y equal to 2x square as compared to y equal to x square. In a similar way, if we draw the graph of y equal to 3x square, it would be more steeper as compared to y equal to 2x square, and so on. So if we decrease the magnitude of the leading coefficient, say y is equal to half of x square, in that case, the steepness of the curve will decrease and it would be something like this. So we can say that whenever we increase the magnitude of the leading coefficient, the steepness of the curves increases and vice versa. Now, if we consider the value of leading coefficient to be minus 1, in that case, we'd be getting y equal to minus x square as a quadratic equation. And if we plot the points, then we'd be getting this parabola, that is a downward parabola, where all the values of y would be negative except at x equal to 0, where it is attaining the maximum value of 0. In a similar way, this graph will be representing y equal to minus 2x square, and this green curve would be representing y equal to minus 3x square, and so on. In a similar way, if we want to draw the graph of y equal to minus half of x square, in that case, the graph would be something like this. That is less steep as compared to y equal to minus x square. So we can see that the leading coefficient A indicates the steepness of the curve. That is, if the magnitude of the leading coefficient is higher, the steeper the curve would be. Also, we can see that if the leading coefficient A is greater than 0, in that case, we'd be getting an upward parabola. And if the leading coefficient A is less than 0, in that case, we'd be getting a downward parabola. Now, let us consider this quadratic equation where the constants B and C are non-zero, and let us see how we can plot the graph of such kind of quadratic equations. Well, before moving ahead, let us revise some of the concepts that we have learned in the quadratic equation videos. First, the standard form of a quadratic equation is given by y equals to ax square plus bx plus c, where a is a leading coefficient and it is non-zero, and b and c are some constants. And if the leading coefficient is greater than 0, in that case, we'd be getting an upward parabola, which would be giving us a minima point, and we'd be getting a minimum value. In a similar way, if the leading coefficient is less than 0, we'd be getting a downward parabola, which will give us a maxima point or maximum value. The two roots of the quadratic equation is given by minus b plus minus under root of b square minus 4ac upon 2a, where b square minus 4ac is called as the discriminant of the quadratic equation, which we generally denote by capital D. The maxima minima point or the point of symmetry can be found out simply by using x equal to minus b upon 2a. And if the discriminant is greater than 0, in that case, the roots would be real and distinct. That is, the quadratic curve would be crossing the x-axis at 2 points. And if the discriminant is equal to 0, in that case, the roots would be real and equal. That is, the quadratic curve would be crossing the x-axis at only 1 point. Also, if the discriminant is less than 0, then there won't be any real roots. That is, the roots would be imaginary, which indicates that the quadratic curve won't be touching the x-axis. Now, let us come back to this quadratic equation for which we want to plot the curve. For plotting the graph of such kind of quadratic equation, first, let us find its roots, which we can find simply by finding its factors. So, x square minus 9x plus 18 can be written down as x minus 3 times of x minus 6. Now, the points at which this quadratic curve will attain a value of 0 can be found out simply by equating this part to be 0. So in that case, the two roots would be x equal to 3 and x equal to 6. That is, at x equal to 3 and x equal to 6, this curve attains a value of 0. And here we can see that the leading coefficient a is greater than 0. So the curve would be an upward parabola. Also, at x equal to 0, the value of y, that is the y-intercept, would be 18. Now, if we consider all these points, that is at x equal to 3 and x equal to 6, the curve attains a value of 0. At x equal to 0, the curve attains a value of 18 and the curve is an upward parabola. In that case, we'd be getting a curve which would be something like this. That is an upward parabola which is crossing the x-axis at x equal to 3 and at x equal to 6. And since it's an upward parabola, so it will attain a minimum value, and the point at which it will attain its minimum value we can find simply by using x equal to minus b upon 2a. For this quadratic equation, we have the value of a to be 1 and the value of b to be minus 9. So x equal to minus b upon 2a would be simply minus of minus 9, that is plus 9 upon 2 into 1, that is 2, which would give us 4.5. So that's why at x equal to 4.5, this curve is attaining a minimum value. And if we put this x equal to 4.5 in this quadratic equation, in that case, we'd be getting the minimum value, which would be minus 2.25. So this curve attains a minimum value of minus 2.25 at x equal to 4.5. At x equal to 0, we are getting the y-intercept, which in this case is 18. So this length would be the y-intercept, which would be 80. Also, if we find out the discriminant for this quadratic equation, in that case, this would be b square minus 4ac, that is minus 9 square minus 4 times of 1 times of 18. And if we simplify this, this would be 9. So the discriminant is 9, that is greater than 0. So we can say that the roots are real and distinct. And from the graph also, we can see that the roots are real and distinct. So in this way, we can plot the graph of any such quadratic equation. Let us consider one more example, y equal to x square minus 2x minus 8, and let us try to plot the graph of this quadratic function. Again, if we factorize x square minus 2x minus 8, in that case, the two factors would be x minus 4 and x plus 2. So if we equate this part to be 0, in that case, the two roots would be minus 2 and plus 4. So that means the curve would be crossing the x-axis at x equal to minus 2, say somewhere here, and at x equal to 4, say somewhere here. Again, here the leading coefficient is positive, so we'd be getting an upward parabola. So we'd be getting a minima point, and we can find the minima point simply by using x equal to minus b upon 2a. That is minus of minus 2 upon 2 into 1. As the value of b here is minus 2 and the value of a is 1. So this would give us the minima point as 1. We can also find the minima point directly by taking the midpoint of the two roots. Here the two roots are 4 and minus 2, so the midpoint would be 4 minus 2 upon 2, that is 2 by 2, which would be 1. So either we can use this x equal to minus b upon 2a, or we can directly take the midpoint of the two roots to find the maxima or minima point. So for this quadratic equation, we have the two roots as minus 2 and 4. It's an upward parabola and the minima point is at x equal to 1. So if we use all these points, we'd be getting the graph, which would be something like this. That is roots at x equal to minus 2 and 4, minima point at x equal to 1, which is giving us the minimum value as minus 9, which we are getting simply by putting x equal to 1 in this quadratic equation. So this graph represents this quadratic equation. Also, sometimes instead of y equals to x square minus 2x minus 8, we might have been given as y equals to mod of x square minus 2x minus 8. In such cases, again, we'd be drawing the graph of x square minus 2x minus 8 first, and then we'd be drawing the graph of y equals to mod of x square minus 2x minus 8. Y equal to mod of x square minus 2x minus 8 simply means that y will always take positive value. So all the negative values of y in this quadratic equation will become positive in this quadratic equation because of this modulus function. And we can see from this graph that from x equal to minus 2 to x equal to 4, this graph attains negative value. So all these negative value will become positive for y equals to mod of x square minus 2x minus 8. So if you want to draw the graph of y equals to mod of x square minus 2x minus 8, in that case, all the negative values of y in this quadratic equation will become positive and everything will remain the same. So the graph would be something like this. That is, all the values of y remains the same except the negative values has now become positive. So in this way, we can draw the graph of a quadratic function inside a modulus sign. So that's it for today's video, in which we have seen how we can plot the graph of quadratic functions. And in the next video, we'll be seeing how we can plot the graph of modulus functions and so on. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I'll see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.